So, processing text files by looping through the lines of text and looking for individual strings and manipulating those strings bit by bit is a fine way to do things, and sometimes that's what you need to do. But it turns out there's a better way that makes things a little bit simpler, and that better way is with something called regular expressions. Regular expressions are a general purpose tools that are in Python, but also every other programming language as well, that let you look for patterns in text and extract and match patterns within a text string. It turns out this is so common that regular expressions are a powerful and general way of making it much easier to do this. So we're going to look into them. Before we go back to our FYI files, let's start with a much simpler kind of string. Let's just look for a sort string. Maybe someone just has typed in something like my age is 49. Suppose you have a string like this and you want to extract the person's age. Well, if you know the exact structure of the string, you could use the kind of thing we did before, and we can use regular expressions to do this as well. So let's do the regular expression equivalent of looking for my age is and then getting the rest. Well, in order to do that, first we have to import the regular expression module. We just say import RE for regular expression. And now what we can do is use the RE module and call the findAll method. And there's a bunch of useful methods, but we'll start with findAll. And what we can do is say what pattern we want to look for in the data. So you take two parameters. The first is the pattern, and the second is the data. So the pattern we want to look for is to say any sequence of digits. A digit is 0 to 9, and the regular expression to say any one of a specific series of characters is you can use square brackets and then say something like 0-9. So what this says is I want to I want to look for the pattern of any digit 0 to 9. So the square brackets in 0 to 9 means one of those characters. Then what I want to do is use another regular expression, special pattern character, which says I want to look for the pattern that has one or more digit. And plus is the special symbol that says I want one or more of the previous regular expression. So what this pattern here says, I want one or more digit, 0 to 9. And if I do that, that's going to return a set of matches, which is a special regular expression data structure. And I can say if there were in fact any matches, if the length of matches is greater than 0, then let's print the first one. And if we run this, look at this, it extracts and prints out 49. So a little bit complicated, but it works. And it turns out that regular expressions, you can search for almost anything inside of a string, and you have to learn this special language. There are a lot of subtleties in it, but some of the basics are fairly straightforward. Let's look at another example. Suppose instead we said data is the string he said I love you, in quotes. And maybe data is any sentence, and we want to find out, are there any quotes inside of the sentence? So now what we want to do is look for the pattern, which is single quote, something, and then another single quote. Well, it turns out this is exactly the kind of thing that regular expressions are good at. So I'm going to copy this part and just replace the pattern. Instead of looking for one or more digits, what I want to look for is a quote followed by any number of characters. I'm going to fill that in a second, and then another quote, single quote. So the question is, how do we get any number of characters? Well, any character is matched by dot. Dot is a special regular expression pattern symbol that says match any character. And now what we want to do is say any number of characters, 0 or more. So just like plus was a special symbol that said one or more of the previous expression, star is the special symbol that means 0 or more of the previous expression. So what this is going to match for is quote, then any number of characters, and then another quote. And then we'll print out if we find it. And look at that. It printed 49 from the first example, and it extracted I love you. And to prove this works, right, this will work no matter what is here. You can say I hate you, right, and it matches I hate you. Or maybe, say whatever you want here. I'm not going to use that one. He did not say I hate you. And it still extracts I hate you, right? Because it doesn't matter what's before here. I'm not going to get into what would happen if there was another single quote in the middle of that. That might have gotten something different, but that's a little bit more of a complex situation. Okay, so this is good for finding single patterns within a string. Another thing that often happens when we're looking for data is that you'll have a string with multiple elements and you want to find all of them. So suppose that we had the sentence, cats are smarter than dogs. And we knew that this was an example of a whole pattern of sentences where it was something are smarter than something else, and we want to find out what the two things are. Well, again, we can do something kind of similar. But instead of using the find all method, we're going to use something else called the match method. Like find all, match takes a pattern and it applies it to a string. But what we can do with match is it gives us a bunch of other opportunities. So how do we, what are we searching for here? Well, we first want to identify the thing that happens before are smarter than. And if we want to match a particular element and pull it out, what we have to do is put it inside parentheses. So I'm going to say dot star, like we did before, that says look for anything, but it's not going to match the whole string because then we're going to have some other things here as well. Are smarter than, and then another dot star. And then notice there's a sentence, this is a sentence, so there's a period at the end, so I'll match period at the end. So what this is going to do is this will match this regular expression where the first element within parentheses is going to be forced to match to this, and the second set of thing in parentheses is going to be forced to match to this. Now, when it does this regular expression match, I can ask for the groups that were found, and the groups is the special method that match offers you that correspond to these parenthetical elements. Let's store this in groups and print out the groups that it found. Let's run this and look what it did. It gave us a tuple, which is like similar to a list, with cats and dogs. Right? So this is kind of cool. It, in this single line, pulled out just the elements we wanted. And if we had changed this to be cats are smarter than ants, well, and we run it again, it'll still work. Right? It printed out cats and ants. This gave us just what we wanted. All right, now we know enough to replace our string processing that we were looking at earlier with regular expression processing. So let's go ahead and put in the bit of code for accessing an FYI file and see how we can do that. I've gone ahead and just written this basic structure to open an FYI file, iterate over each line, and I'm going to use a regular expression match. So what are we going to look for? Let's look for that subject. Right? We want to look for lines that start with subject, and then we want to get the rest of the text after the subject. So we'll go ahead and put inside of parentheses dot star. So for each line, this will look for subject colon and then match on everything after subject. Now, not every line is going to match, so I can't go ahead and call groups on this right away. I first have to see if there was a match. So let's store this in a variable called match, and then say if match exists, that is if it's not none, then we can go ahead and get the groups from match. And then for each group in that list of groups, let's go ahead and print it. And go ahead and run this. And look what we get. All three subjects. And similarly to before, right, we can go run this on FYI3 and we'll get all 26 of them. And it works just fine. So right, this is much, much nicer. We didn't have to do all of that low-level management of exactly what was in the sequence of characters. Instead, we can kind of use this regular expression at a higher level to match the patterns that we're looking for.